Hello dear friends, welcome to the channel. We have a very nice trigonometric equation today. We have sine to the fourth power is equal to cosine squared, and we want to solve this for real x values. Now my friends, let me remind you that the trigonometric identity we have sine squared plus cosine squared for any angle is equal to 1, and we will use these. Let me just isolate this sine squared x and write 1 minus cosine squared x, and we will plug this into our equation. Now since the fourth power here can be written as squared against squared, we can say we have sine squared against squared. This is equal to 1 minus cosine squared all squared, and it's equal to cosine squared again. Now this is an equation of cosine squared x. Let's just substitute some t. Let t be cosine squared x, and try to solve for t first. We have 1 minus t all squared is equal to t. Now let's expand this. We have 1 minus 2 times t plus t squared. This is equal to t, and having everything on the same side, we will write t squared minus 3t and plus 1 is equal to 0. Luckily, this is an easy quadratic now. We can use the quadratic formula, that is t is equal to minus 3 becomes plus 3. We have plus minus square root of minus 3 squared is 9 minus 4 times 1 is 4. So we get a 5 divided by 2 times 1, which is 2. These are the solutions for t, but t is equal to cosine squared. Let me try to show you now. We have first t is equal to, as I said, cosine squared x is equal to 3 plus root 5 divided by 2. This is a special number, this 3 plus root 5 divided by 2. Let me show you. We will square root both sides and write cos x is equal to plus minus the square root of this number. 3 plus root 5 divided by 2. And the square root of this number is, let me just continue here, multiplying by 2. We will have 6 plus 2 root 5 divided by 4, and this is now equal to, let me just write here, cosine x is equal to plus minus the square root of this 6 plus 2 root 5 divided by square root of 4, and using some rule, we need two numbers. They multiply, their multiplication is 5, and they add up to 6. They are 5 and 1, so we will have root 5 plus root 1, or just 1, divided by 2 plus minus. This is plus minus the golden ratio phi now, but phi has a approximate value as 1.618 and so on. So cosine for real x's cannot be equal to something greater than 1 or something less than negative 1. We have no solution in this case. Cos x equals plus minus the golden ratio has no solution in R. Let's look at the second case. We have cosine squared is equal to 3 minus root 5 divided by 2, and the same trig gives cosine x is equal to root plus minus, say, plus minus root 5 minus 1 divided by 2. And since root 5 is approximately 2.2, subtracting 1 we will have 1.2, and divided by 2 we will have 0.6 plus minus. So this has solutions. Let's write. We can find the first solution from cos x is equal to root 5 minus 1 divided by 2. Then x is equal to arc cos or cos inverse of this root 5 minus 1 divided by 2 plus, say, 2 pi k, for k being any integer, and let's call this A part. B part is similarly cos x is equal to the minus versions. So we have 1 minus root 5 divided by 2, and we will write similarly x is equal to arc cos or cos inverse of this 1 minus root 5 divided by 2 plus 2 pi m, let's say. These are the solutions for our trigonometric equation. Thank you for watching me, and see you in the next videos.